page 319, number 46. Okay. Okay, so it says, suppose f of x has a positive derivative for all values of x, and that f of 1 equals 0. Which of the following statements must be true of g of x equals the integral from 0 to x of f of t dt. All right, so g is a differentiable function of x. All right, well, that's true. Some property that states that, well, it says f of x has a positive derivative for all values of x, and then your thing is going from 0 to x, and so g is differentiable. That's true. G is a continuous function, so yes. So both of those are coming from theorems. I have to flip through the book to find which ones. Where are they? Talks about in your book, Fundamental Theorem of Calculus, Part 1, it states that if f is continuous on that interval from a to b, then the function, which basically looks like this guy, g of x, has a derivative at every point x. And so if this guy has a positive derivative for all those values or whatever, then it's differentiable and it is continuous. And then C says the graph of g has a horizontal tangent at x equals 1. All right, so the graph of g has a horizontal tangent at x equals 1. All right, well, if it has a horizontal tangent, then that means that g prime at 1 would equal 0, right? Because that would be a horizontal tangent, would be a slope of 0. And so g prime of x would be the derivative of this guy, which is just f of x, right? And they gave you that, so g prime of 1 would be the same as f of 1, and they said that that value was 0. Right here, that was given. And so if your derivative is 0, then there's a horizontal tangent there. That's what that means. So that means that that's true. G has a local maximum at x equals 1. So for it to have a local maximum, G has a local maximum at x equals 1. Or part E says G has a local minimum at x equals 1. So if we have a max, then that means your derivative goes from positive to negative, right, at x equals 1, versus if there's a minimum, it's going to go from a negative to a positive, and we know at 1 it's 0, and so, and it says f of x has positive derivatives for all values of x. Positive derivatives. F of x has positive derivatives for all f of x. So to me, I'm thinking it's got a local max. It's going from g prime, so the derivative of it, so f of x would be going positive to negative, for negative to a positive, how do we know? Well, the fact that I think it has to do with the whole thing that the derivatives are all positive, right? After 0, but then 1. So if 0, if your g prime is 0 there, and it's positive after that, okay, I gotta think more on that, the reasoning behind it. I'm thinking it has to do with the positive derivatives, though. Okay, let's move on. Nothing this complicated is going to be on the test. I'm trying to think of what else. They didn't give you a graph. They didn't give you an equation. They didn't give you. Yeah, we're going to be giving you like the graph and stuff. So I'm going to move on from here and let's answer questions that, because it's probably something really simple like what I just said about them being positive, but I don't want to say something wrong. So you don't have to worry about something like that. Next question is from the quiz 15G. How did you know that the answer is 0 and not 4? Okay, now something like that will be on the test. So quiz number 15G asked for where does F achieve its maximum on 0 to 4. So what we know is it achieves its max when F prime goes from goes from being positive to going to being negative, right? And the graph that was given to you looked like this, right? Where that's 4 and that's 2 and that's 0. Okay, and this graph was, they told you it's f of x, but then you also figured out that this is also big F prime. Okay, so when does big F prime go from a positive to a negative? Well, it doesn't. It doesn't happen, right? It doesn't go, when I say it, let me rephrase that, make it better. Come on. Oops, too many. F prime of x does not go from positive to a negative. Right? It doesn't go from above the x-axis to below the x-axis. It goes from negative to a positive, but it doesn't go from a positive to a negative, above to below. And so you got to check the endpoints. So it's when F prime goes from positive to a negative or at the endpoints. And so that's what you had to do is you had to check the endpoints and let's see, and you've got it achieves a minimum of 2, and then what did we say? So F would be, the maximum would be when it goes from a positive to a negative, and you're going from a right endpoint of 0, but then your F prime is 0, and then it starts decreasing, and then it's increasing. It wants a maximum value. So this area here, the area of the semicircle was negative pi over 2, right? Here was negative pi over 2 up until there. And then the area all the way to here, this area here was a positive, what, 1/2, 2 times 1. So this area was a 1. So this is like a negative 1.57, and this is an area of 1, and so that 1 didn't overcompensate. When you go through the whole thing and add them all up, at 4, the area is still, so at x equals 4, your area is still a negative, it would be negative pi over 2 plus 1, which is about negative 0.57, right? And so that's still bigger than at 0, the area is 0. And so the maximum is happening at x equals 0 because 0 is bigger than a negative number. 18 from the multiple choice worksheet, I'm assuming. Number 18. It is the integral from 1 to rad x of 16t to the 9th power dt, and they want dy dx. And so you want to take the derivative of this guy, which is just going to be plugging in the rad x into your t and then raising it to the 9th power, but then times chain rule, and the chain rule of x to the square root of x is the same thing as x to the 1/2 power, and so the derivative of that would be a 1/2 x to the negative 1/2. So that gives you what, an 8x to the 9/2 times an x to the negative 1/2, which is an 8 times x to the, keep the base, add the exponents, which is an 8x to the 8 over 2, which is 4. So it's fundamental theorem of calculus where you take whatever is in there and you plug it into the t, but then if it's not just a regular x, then you got to do chain rule and take the derivative of what that was there. All right, that was 1823. Find the area of the shaded region. And it gives you the graph. It gives you the graph, and it gives you y equals x cubed minus 4x is your equation, right? And then, but it gives you the graph, and it does this thing, something like that. So they want you to find that, and then it also tells you that's 2, and that's 3, and that this is 3, 15, and that's 0, 0. Okay, so to find the area, you're going to use integrals, but you got to split it up because you've got this area below the graph, right? So that area will end up being negative when you take the integral of it from 0 to 2, and then you need to also add it to the area from 2 to 3. So 2 to 3 it's positive, but 0 to 2 it's negative, and so I would do the negative, right? You can also go and take the antiderivative and then throw absolute value on each piece, but you do have to separate it into the part that is below the x-axis and then the part, oops, that is above the x-axis. It's still an x cubed minus 4x ex. Okay, so antiderivative would be 1/4 y to the 4th, because I'm adding 1 to the exponent, right, to make it a 4, but then you got to divide by it. So you're doing reverse pop and drop. And then this would be an x squared now, but then divided by 2. 4 divided by 2 would give you a 2. And that you're evaluating from 0 to 2. And then we're going to add that to same derivative, 1/4 x to the 4th minus 2x squared. And we're going to go from 2 to 3. Now you'll see in a minute here when I go to do this that when I evaluate this guy from 0 to 2, it'll be a negative. So I get 1/4 times 2 to the 4th would be 16 minus 2 times 2 squared is 4. And then when you plug in a 0, both of those end up being 0. So this ends up being a negative 4 minus 8. So see how that area underneath there is a negative 4? It's because it's below the x-axis. And then this one will be 3 to the 4th is 81. So 81 over 4 minus 3 squared would be 9, times 2 would be 18, and then we're going to subtract from that. So put parentheses there. Plugging in a 2 to the 4th is 16, and then it's over 4, and minus 2 times 4 minus 8. And so this ends up giving you a what? That's a negative 4, so plus 4. So 81 over 4 minus negative 4, so minus 14. Now, that will end up being a positive value, right? Yes, I did it right. I did it right. Of course, I left my flipping calculator in my bag. Okay. And so you should end up with, let's see, 4, that's a 4, so a minus 10, 81 over 4 minus a 10s, which is 40 over 4, so 41 over 4. All right, not too shabby without a calculator. I might have to grab my calculator if another one gets bigger than that. But, all right, that was number 23, page 306, number 62. It says find f of 4 if 0 to x of f of t dt is x times cosine of pi x. Find f of 4 if, all right, so, well, I know f of x would be the derivative of this guy. That's just by definition by the fundamental theorem of calculus. F of x would be that. So that means I need to take the derivative of x times cosine of pi x. That's product rule, right? This is cosine of pi x and then but times x. So product rule says derivative of x is 1 and then times cosine of pi x. And then plus x times the derivative of cosine of pi x, which would be a negative sine of pi x, but then times, chain rule says go inside and multiply times the derivative of pi x, which would be pi. All right, so that means I get a cosine of pi x minus pi x times sine of pi x. All right, so that's your f of x. So now if I want to find f at 4, I'm going to plug 4 into all of those x's. So you get cosine of 4 pi minus 4 pi times sine of 4 pi. Cosine of 4 pi is 1, because that's just coterminal with 2 pi. Sine of 4 pi is 0. get minus 0, and so your answer is just 1. Page 319. Okay. So page 319, 38b says, find the average value of y equals a times rad x over the interval from 0 to a. All right, so average value of a function is 1 over, okay, don't be confused, it's not the same a, right? But 1 over b minus a times the integral from a to b of your function, f of x. F of x dx. All right, so now your interval is going, so that means the average value for this guy will be a 1 over a minus 0, because now your interval is from 0 to a, and then times the integral of 0 to a of a times rad x dx. So a, you're considering a constant right now. So this is a 1 over a times the integral of 0 to a times, I'm going to rewrite rad x as x to the 1/2. Right? Well, a is a constant, so when you pull the constant out, then that a is going to cancel with that a, and so you're just integrating x to the 1/2. So 1/2 plus 1 would give you a 3/2, but then you need to go divided by 3/2, so 2/3, and you're evaluating that from 0 to a, which gives you a 2/3 a to the 3/2 minus 0. And what did they say it was? Yeah, so then that's 2/3 a to the 3/2. So yeah, average value of a function, you're going to use that where that's on the interval from a to b. Average value over interval from a to b is given by that. All right. I don't see any more questions. What else you got for me? On the quiz. Okay, so they want you to find the integral of from 0 to 3 of f of x dx, and they gave you, so this is what they want you to find, but you were given the integral from 0 to 10. Oops, that 10 is a little off there. You were given 0 to 10 of f of x, and that was equal to 12, and they also gave you the integral from 3 to 10 is -5. Okay, so for 0 to 3, what you can do, you've got these guys, right? And that's it. So you can go from, let's see, we can go from 0 to 10 plus 10 to 3. Now that doesn't look normal because you're not used to going backwards, but you agree that 0 to 10 plus 10 to 3 would give you 0 to 3. Yeah. But we don't have 10 to 3, but we do have 3 to 10. And what we know is that this is equal to the negative of from 3 to 10. They're opposite in sign. You go the opposite direction. All right, so that gives you a 12 minus a negative 5, which gives you 17. That's quiz 11. You're welcome. Number 6. All right, so they gave you y equals and they want you to find dy dx. So dy dx will be taking the derivative of this integral they gave you because they told you that's y. So 3x squared to 5x of the natural log of 2 plus p squared dp. Okay, so fundamental theorem of calculus says we can do this if we split it up, right? We can use fundamental theorem of calculus if there's a constant at the bottom. And so I can definitely split this up of, this is from 3x squared to pick a constant, any constant. 0 is usually your easiest one. Anytime you can use 0, you should, because it just makes life easier. And then plus the derivative of from 0 to your upper limit. So all I did was stick a constant right smack dab in the middle. And again, you can use any constant, but when you use another number, you got to remember you got to plug that number in to your antiderivative. So that's why 0 is the nicest one to use. Okay. So we got that, and then what you really want, though, to be able to use the fundamental theorem of calculus is we need the 0 on the bottom on this first one. So I can do that by just throwing a negative in front, and now I can flip my integration limits. So now it'll be from 0 to 3x squared. Like that. Second one is fine because the 0 is on the bottom. And now I can use fundamental theorem of calculus, which says, all right, I got a negative here. You're going to plug that 3x squared into the p, but then it's not just an x, so you've got to do chain rule. So it's a negative of the natural log of 2 plus, plug in the 3x squared into p, and then square it, right? But then times the derivative of 3x squared would give you 6x. So that's chain rule right there. This part is chain rule. You have to take the derivative of the 3x squared. And then plus plugging in the 5x into p on this one. And then we square it, and then times, you got to take the derivative of 5x, which would just be 5. And again, that part was just chain rule. Okay, and so cleaning this up just a little bit, I wrote my answer as negative 6x times the natural log of 2 plus 9x to the 4th, and then plus 5 times the natural log of 2 plus 25x squared. And that's how I left my answer. All right. Quiz number 12. All right. So what values of k for which 2 to k of x squared dx is equal to 0. All right, well, when is this 0? Remember, the rule is that if you take an integral of a to a of any function, doesn't matter what it is, then it's 0, because you're finding the area from a to a, right? So what value of k would make this integral equal to 0? Well, when k equals 2, then you would have from 2 to 2 of, doesn't matter what the function is, when you take it 2 to 2, it'll end up being 0. So k equals 2 is your answer. That one. How do you know when to include chain rule with the fundamental theorem of calculus? All right, anytime it's not just an x. So fundamental theorem of calculus says, well, part 1, right? Hopefully I remember it. Part 1 says, if you take the derivative of an integral from any constant, I'll just put 0 to x of f of t dt, then it's just f of x. You just plug that x right into the t, like whatever that is, right? So if all you have is d dx of from 0 to x of, let's go, t squared dt, right? Then your answer would just be x squared and done, right? However, if you have anything other than just an x up there, then you've got to do chain rule. So anything more, good luck, anything more than just x, then chain rule. So for example, on that last one that we did, you know, it went from 0 to 5x of blah, 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 right? So you had to do, you plugged that 5x into the function, but then times, right? So you plug in the 5x and then do chain rule on 5x, which means multiply by 5. Or I think we did another one where it was from 0 to rad x, right, of blah, 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 whatever it is. You know, you had to plug in rad x and then do chain rule, which meant multiply by 1/2 x to the negative 1/2. So always chain rule. If it's not just an x up there, then you got to do the chain rule of what is the derivative of what's sitting in there. Plug it in and then do that. Okay, number 13. Yes. I feel like 13 was more of a matter of, did you remember, they wrote the answer weird, which sometimes the AP, sometimes College Board does that. So you just have to be able to match up your answer, which maybe you simplified more to what theirs is. But, okay, so it says 3 equal subdivisions from -2 to 4 are used. And so from -2 to 4, and they want 3 equal subdivisions, so like that. To figure out what that distance is, you just go 4 minus -2 and divide it by the 3 subdivisions, which is 6 over 3, so 2. So this distance here is 2 and 2 and 2. And so that makes that a 0 and this a 2. Yeah, and then your trapezoidal approximation. So the trapezoidal rule is h over 2, so 2 over 2 times plugging in your function. Sorry, I didn't write your function down. Go away. Okay, so the function they gave you, okay, use out of that. It was a -2 to 4 of e to the x over 2 dx. So we're approximating this. right? And so using trapezoidal rule, it's h over 2, so 2 over 2, times, on the first guy, you're just going to plug that negative 2 into x, so e to the negative 2 over 2. And then plus your middle guys, you'll multiply by 2, so 2 times e to the 0 over 2, plus 2 times e squared over 2. And then the last one you don't multiply by 2 because it was only counted once in your little trapezoid. And so this was just an e to the 4 over 2. Because I'm plugging all of those values into this function there. And so, I mean, I would have written my answer with just this inside there, right? I would have written my answer as negative e to the negative 2 over 2 plus a 1 plus an e squared and plus an e to the 4th over 2. That's how I would have written my answer, but yet this is a multiple choice question. And so I went and looked and I'm like, well, frick, none of my answers are there. And if you recognize that part D, if you just and then rearrange crap too. They factored out the 1/2 from all of the terms, and then they wrote the e to the 4th first, and then the e squared, which means you need to multiply by 2 to get that guy, and then they even left the 2 e to the 0. They didn't even say that was 1, so okay, and then plus e to the negative 2, which was D. Just recognizing that not always is your answer. You have to look among that multiple choice to see if yours is just written differently. All right, what else? Six, 3 notes. Yes. It's not something that you'll see very often. You usually see 1 through 5 the most, right? But it's actually a pretty simple thing of what domination is. It tells you f of x is greater than or equal to g of x. These are like y values of two functions, right? So let's say, I'll do something simple like, let's say this is f of x. Nope, I'll say that one's g of x because I ran out of room. Come on, back up. Boop. Okay. Let's say that's g of x, right? And then let's say this is f of x, right? F of x, all of the y values of f of x are larger than all of the g values of, or the y values of g of x. And let's say that it's true for the whole thing, right? All the way down the line. Well, when you're going to find the integral of, from, let's say, from a to b of f of x, so let's say here's a and here's b, what you're finding is the area under the curve to the x-axis. So you're finding all of this area, including all of that guy, right? That's what you're finding. That's this guy, the area under the curve of f of x. And then if you're finding the integral from a to b of g of x, you're finding the area under the curve from a to b, right, under g of x to the x-axis. So just that portion is this guy. And so obviously the area of f of x is much larger than the area of g of x, under g of x. So that's domination. That's all it's saying. One of them is bigger than the other. What else? 321, 36. All right, so it says it gives you this function is a piecewise function, and that it is x squared for when x is greater than or equal to 0, but x minus 2 for when x is strictly less than 0. It says it's discontinuous at 0, which is definitely true, but integrable on -4 to 4. And they want you to find the integral from -4 to 4. Well, I guess you technically don't even need the picture. If this is where it's changing or splitting up, x squared is positive. Well, no, we better draw a picture because what if it ends up being negative somewhere? Okay, so y equals x squared is a parabola opening up. So the first branch looks like this. For x is less than 0, x minus 2 means you got a minus 2 open dot there, but then a positive slope. So come on. It's like that. That's going to be your x minus 2. -2 is your y-intercept, slope of 1, but it's all of the x values going less than it, and this guy is going that way. And then if we only want from -4 to 4, well, all right, so when x is -4, we end up in -6. So let's say here's -4, right? And then to 4. So yeah, that's going to be way up there. We want all of that guy, which it goes way up higher than that. Okay, so we want this area here. And so what you want to do is split it up, right? You need to go from -4 to 0 of your function x minus 2. And then from 0 to 4 of x squared. And those are easy to do, right? 1/2 x squared minus 2x, and we're going to evaluate that from -4 to 0. And then here you got a 1/3 x to the third, and going from 0 to 4. And so that would be a 0 minus, plugging in a -4 would give you 16 over 2 is 8, minus, what is that, -8, so that's a +8. Yep. And then plus 4 cubed is 64 over 3. Did I do that wrong? Wait, -4, okay, wait, 0, 0, minus -4 would be 16 divided by 2, and plus 8. No, okay, I'm good. And then 64 over thirds minus 0. All right, so what is that? A -16 plus -16 plus 64 over 3. Getting a common denominator, so 3 and times 3, -48 plus 64 is a 16 over 3. Are you going to see piecewise functions? You can definitely see something like this Is it given to you as a piecewise function exactly like this? I don't know. I don't remember. But definitely having, for sure, you will absolutely see that you've got to split up your graph from when it crosses the x-axis. Like that's for sure, no question. No. And so here, I don't remember. The difference here was it wasn't just one function that crossed over. You've got two different functions. Yeah, it's possible. I'm not sure, to be honest with you. I'd be prepared for it. I don't think that was that hard. It looked scary in the beginning, but oh. Y'all are quiet tonight. Does this mean you're really ready for this test? I hope that's true. The better you guys do, the easier they are to grade. Nobody's typing questions. Am I still connected? I still see a red dot of recording, so I hope so. Am I current on the chat window? I am. Nobody's typing. Does that mean we call it quits early? Sure. Got me scared there for a second that y'all left me. I was in here all by myself. Okay, so this is a straight up change of notation, right? So they want you to rewrite this limit as a definite integral. 1 minus c sub k over square root of c sub k delta x, and then on this interval from 4 to 8. All right, so this is going to be your function. This is going to be your f of ck. This you're going to change to dx, and these give you your bounds or your limits. Right? So this is equivalent to the integral from 4 to 8, because those are your limits. You just change your ck's to x's. So a 1 minus x over rad x, and you change that delta x to dx. And that's it. I know it looks really scary and horrible, but it's actually just changing notation. That's it. Page 3, 1925. Okay. So we're integrating from 0 to 1 of 36 over 2x plus 1 cubed. So what I would do is rewrite this so that it's from 0 to 1 of 36 times 2x plus 1 to the negative third power. Right? This is a constant, this 36. You could pull it out front, and that way you don't have to worry about it anymore. I shouldn't say that. You take your answer and multiply it times, dx, times 36. But it just kind of gets it out of the way, right? And so when you go to take the antiderivative, what you're doing is doing the undoing pop and drop, right? So pop and drop, you would have taken your exponent, popped it in front and multiplied, and then dropped the exponent by 1. So when you do the reverse, or you undo that, what you're going to do is you're going to take the inside, right? You're going to take this negative 3 and you're going to add 1 to it. So you're going to add 1 to the exponent, which gives you a negative 2. But you would have popped that in front and multiplied by a negative 2. So you got to undo that by dividing by negative 2, or that's the same thing as multiplying by negative 1/2. Yeah. And then the other thing you have to do is when you went to go take the derivative, you would have had to take the derivative of the inside, the 2x plus 1. So you have to undo chain rule. Chain rule would have been multiplying by 2. So I'm going to multiply by 1/2. So this part right here is undoing chain rule from that guy, right? So, and you're evaluating it from 0 to 1. So let me just simplify this really quick, and it would give me a, what, negative 1/4 times 2x plus 1 to the negative 2 power. Which, if you go and just double check yourself, right, I'll plug these values in, but if I come over off to the side and do maybe yellow, maybe, let's see if I have enough room. What is the derivative of the negative 1/4 times 2x plus 1 to the negative 2? You would have taken the negative 2, popped it in front, so that it would be a negative 1/4 times the negative 2 times the, keep the inside, drop that exponent by 1, negative 2 minus 1 would give you negative 3, but then chain rule would have said, now multiply by the derivative of the inside of these parentheses, and the derivative of 2x plus 1 would be 2. And so when you multiply that out, you'd have a, what is that, a positive 1/2 times 2, so a positive 2x plus 1 to the negative 3rd power, which is absolutely what we have here. So I definitely took the antiderivative correctly. You can always double check yourself that way. And even if I had not pulled that 36 out front first and I still had a 36 in there, you would have ended up with the same thing also. All right, so we've got 36 times, what is that, a negative 1/4. Well, actually, let's go ahead and, that's a constant, so let's go ahead and divide that 36 by negative 4. Come on, boop, 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 undo. Oh, oops, shoot. All right, so that was, this guy matched that guy. Okay, so now you can definitely pull that constant out. 36 divided by negative 4 is a negative 9. And then we'll go times, plugging a 1 in would give you a 3 to the negative 2. And then minus plugging in a 0 will give you a 1 to the negative 2 power. And negative 2 power means take the reciprocal, so it's a 1 over 9. So what is that, a negative 9 times 1 over 9 minus 1, which is a negative 1 plus 9, which is 8. Is that the answer? What number was this? Yep, there you go. All right, what else? You're welcome. You guys got nothing for me? We can call it quits early if you need to. I feel sorry for anybody that's going to watch this recording. Sit there and wait. Do, 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 do. No? Anybody else have any other questions? Nobody's typing. All right, am I calling it early? Oh, somebody's typing now. Will there be a process of slicing and estimating to find the area maybe on the area on the test? Like what type of, I mean, yes, as far as like trapezoidal rule, LRAM, oh, the sphere one, no. That's just that is a prelude to what is coming very soon for you guys. Yay! But no, the sphere one, you do not need to worry about. Nope, nope. Estimating the volume of a sphere, no, don't worry about that one. I don't think so anyway. That would suck if I was wrong, but no, I don't think so. Do y'all think this is an easy chapter? Is that why you don't have any questions? I think this is the deadest it's ever been in here. Or you don't know what to ask? Or you don't want to talk to me? You want to just watch me talk to myself? Make me look like a crazy person? You're still not typing. Okay, well, I don't remember what time I started exactly, but apparently we're done. All right, I'm going to stop the recording.